Hello. Hi, my name's Jack Mccauley. I work at UC Berkeley. I teach environmental engineering, and the last couple years I've been working with climate change stuff. And the angle on that is I'm a car nut, so I've been working on electric vehicle stuff. Prior to that, I worked in entertainment for 40 years. So today's presentation is to discuss, and I'm sure some of you people are familiar with this, the impact that video games have had on AI, which is substantial. Not in the way you might think, though. So I typed this into ChatGPT. It's almost entirely incorrect. It gets its data from Reddit and Wikipedia and other places which are openly edited by consumers. And as a result, a lot of the information is incorrect. A few things are right. I was a co-founder of Oculus VR, and I worked at Activision on Guitar Hero as a head engineer on Guitar Hero. So anyways, I thought that was humorous. Grunge named me the top living inventor, along with Jennifer Doudna, and I don't even think that's correct. Probably Elon Musk belongs there, not me. So these are some of the things I've invented over the past 40 years. There's a scrolling mouse. This is before I knew about patents. I was in my 20s, late 20s, and I was working on video games, and I was trying to figure out a way to go into the game without hitting the keyboard. You can walk through the game with the keyboard, but I wanted to do it with the mouse. So I put this wheel on the top, and lo and behold, I didn't know anything about patents. I was kind of pretty young, so I found out later it got patented, but I claim to be the first person to do this. And then the Guitar Hero franchise, I built all their hardware, designed, engineered, most of it, not all of it. And of course, Oculus, going back into 2012, when we co-founded the company, sold to Facebook for $3.2 billion, $750 million in cash, and $2.5 billion in stock. And that was Facebook stock, which is pretty good stuff back then. Oops. So, career credits: chief engineer and co-founder of Oculus, chief engineer at Guitar Hero. I worked on movies. The former speaker mentioned Terminator 2. I worked on that. I worked in entertainment. So this is in LA. I'm from California. And back in the late 80s and so forth, I worked at Kodak Research as a digital sequential logic engineer, which is designing digital logic. I also do software and other stuff. So I did the design in a Sun workstation. There used to be this company called Sun. They're now extinct. It was a fantastic computer, my favorite computer. So essentially, I got the job working on a sound system, an audio system, which was used in Terminator 2, Dick Tracy, Edward Scissorhands. And then that was Dolby beat us out. Dolby won, but it was for Kodak. And it won an Oscar in '94, it was. And so I didn't win an Oscar, the franchise did, So I now teach at UC Berkeley. I'm an alumni. I also work in the administration there in the finance committee. I work at RAND Corporation and MSRI, which is a math institute. I'm a math guy. I'm not a good mathematician, but I like math. So, oops, sorry. This video here is from Terminator 2. This was rendered frame by frame. Some of it is a costuming thing, like the gunshots you see, those are costumed on there. Well, a lot of that was done using the same techniques that are used in GPUs to do the rendering. This particular scene took 6 weeks to render. To play, it takes, you'll see how long it takes to play. Let's try playing it here. There's no audio. That's rendered. That's rendered. 6 weeks. It's a good movie, by the way. I was shockingly good. James Cameron is who directed it. I don't know him. I met him one time. I was in a room. I wasn't involved in the set. But anyways, my point is, this can be done now in a matter of whatever to play it in real time, rendered in real time on what's known as a GPU. That was on a quad-core Sun. There were 26, I think, in a room at the time we were working with that. They were working, I was doing the audio stuff. So this is another video. This is 1993. The video game Doom came out. If anyone played Doom, of course, yeah. I have to be careful with video games. I'll sit down. I'll pay for 12 hours. I can't. It's like an addiction. I avoid them now. But Doom, I spent a lot of time on. It was a groundbreaking game. It uses a lot of some sort of mathematics and logical things that happen in Doom also happen in later video games. So it's sort of groundbreaking. And I will try to play this for you. And I'll show you on the left another video game. This is from 2023. And you can compare them side by side. The game's called Unrecord. It's a really, really great game. It looks photoreal, right? Pretty good. On the right, on the left, 30 years henceforth. I apologize for the violence. That's part of the thing, so. That's the interesting thing is what's happened. It's not that you couldn't do this in 1993, it would just take forever to play. But this plays in real time. As a matter of fact, the scene's being created as we speak. It's being created and played. So, sorry, wrong way again. So what makes that Unrecord game possible is an engine, a piece of software that runs on what's known as a GPU. And a GPU is a graphics processing unit. And essentially what it does is just a few math operations. They're fairly simple, but it does it very, very quickly. I'll show you in another slide what the current state of the art is. So most video games now use GPU to create rich graphics in 2D and 3D. The rich graphics use a large amount of processing power to create the effects in the video game. And I claim without video games and entertainment pushing the boundaries of computing power, there would be no kind of advances we see in AI. So the GPU that's in a video game, like in a Sony PlayStation or a gaming rig on your desk, is what's used in AI. It's the same engine, the same mathematical engine. My claim, see, that it was because of the desire, the consumers wanting more and more and richer graphics is what drove companies like NVIDIA to produce the chipsets. And I remember 20 years ago, the GPUs first came out. This is in the 90s. They weren't very good, weren't very fast, and they didn't run with the standard graphics chipset. You had to stick it on a side card alongside of it in a gaming rig to run it. So this is the claim of my talk, and I'm going to explain to you a little bit about what math is used. It's easy to understand, actually. And so here's the increasing power of GPUs, right? So you can see the Samsung Galaxy S6 at the top there. As you progress downwards, you see ever-increasing power of the GPU, the processing. So the PlayStation 4 has about the same processing power as the Intel ASCII Red 2000. And the Red 2000 is a supercomputer. And so 23 years ago, the computing power of an Intel ASCII Red 2000 was 2408, that 100 billion floating point operations per second. Okay, 2.40, excuse me. And now the PlayStation 4 is creeping up on it. And why is that? Well, the GPU is why. The GPU can do other things too. You can burn equations in it, do math operations in it. It does it very well. So the iPhone 14 is now more powerful than the Sony PS4. Believe it or not, it is, in raw computing power. However, it gets very hot when you run it. I worked in VR, of course, and you could render things in a phone and play them inside of a pair of VR glasses, but the phone gets very hot. I was in China recently. I saw, have you heard of Oculus Quest? Yeah. I was in China. I saw a knockoff of an Oculus Quest. They had already knocked it off, and it was very, very good, actually. It was really good. But it's essentially a Qualcomm phone chipset in it. That's essentially what's in the Quest and this Chinese knockoff I saw. And they managed to get the overheating problem pretty well. So Yeah, it's amazing. And what's pushing these kinds of, you don't need a teraflops to do, trillion floating point operations per second to do SMS and send text messages. It's the graphics part that needs this kind of power. So it's amazing what's happened. And you can see an iPhone 8 down there at the bottom. Okay, so that is 400 billion floating point operations per second. And now we're at 24 teraflops. That's a trillion floating point operations per second. A computer does not work with real numbers very well. The architecture of the computer doesn't work. A real number is like $1.25 is a real number, right? A computer likes 1250. It's called an integer. It likes those. A floating point operation, it has the storage for real numbers in it, but it's not something that the native Harvard architecture computer can manage. Some of them have what's known as a math coprocessor on them, but in general, that's not the case. So the GPU is the go-to for doing these kinds of real number operations, which is what tensor operations are. So here's where we are today. The Titan V, NVIDIA's GPU. This goes into a gaming rig, which is a desktop computer running Windows or Unix. We had a desktop computer running Windows mostly, and you stick it in there and you screw it in and you load the drivers for it, and you get 110 trillion floating point operations per second. It's unheard of. This is just the kind of graphics it gets is like the video I showed you, a side-by-side video. That's what you get out of it. But it also does other things very, very well, which is the math for AI. It really, really does a great job on that. And essentially, graphics and computer graphics and tensor mathematics, which is used in AI, are very similar, just coincidentally. So it's amazing that it can go that fast. So I'm going to do some math here. Does anyone know? Everyone knows what this is, right? The answer. It's 2, right? It's 2. Yeah, pardon me? Yeah, you don't need it. That's integer math. You can easy one. Okay, and so the answer is 2. And what's this? What's x? X is 2. 1 plus 2 is 3, right? It's the algebraic value of x. This is what is in AI, is algebra. It's calculus, but it's mostly linear algebra. Linear algebra, this is a single dimension equation. It occupies one dimension. A 2-dimensional equation goes in a different dimension vertically. This goes horizontally, vertically, and a 3-dimensional goes outward, right? So the kind of math that is used in computer graphics works with 3-dimensional equations like that and multiplies them together, these large matrices of equations very, very quickly. It's specifically designed to do that. That's all it does, really pretty well. It's done more other things too, but it's pretty much what it does. On the Qualcomm Snapdragon chipset that's used in the Oculus Quest and the Chinese knockoff, that has a GPU in it, a powerful one, it turns out. And so it's to generate rich graphics, you need that. It's doing these kinds of operations. Okay, this is not tensor math, which is used in AI. It's very similar. I put this up here because it's a nice, pretty equation I could steal off the web. But essentially, the lower operation, the result L is equal to M and the dot product of N. And it does this very quickly. If you were to follow the sequence of operations to produce the result at the bottom, you would see that it's sequential and logical. And so this is what the GPU does. It's all it does. And the main host CPU grabs the information, the frame, out of the GPU and displays it sometimes, or it's displayed directly out. But this is what's used in AI. Not quite this equation, it's called a tensor mathematics. Tensors are used in quantum physics everywhere. And it's called the Ricci equation. And the history is there was an Italian mathematician and a grad student who came up with this in the 19th century. And theory of relativity uses it. This tensor, tension, means tension. It's used in materials science and analytics for structures and so forth everywhere. Sorry. So This is not what I did for a living. I'm a hardware and software engineer. I didn't work on GPU stuff. I know the science and so forth behind it, but when you create a video game, you have an engine that you buy. It's all set up, and the engine has what's known as an API, or an application interface, and you stick the things in there in the software program you're writing, and it does it for you. It's all hidden and transparent to you using the API. There are three main game engines that are used. That's Unity, Unreal. Unreal Engine is what was running Unrecord, and Crytek, which is a friend of mine's company. So those are the main ones. And you just buy the asset. You gave them, it's not expensive. If you're going to license the product, it gets expensive. You buy the thing and you put it in there, and that's it. It's not that hard to do. You can get assets like desks and things like that, or chairs and stuff, and put it in your game. It's really cool. So that's what people do when they do a video game. But I would make the argument that this is my argument going forward here, is that the AI component is really based on the economics of entertainment drove this forward. I can't imagine NVIDIA creating a GPU just to do AI. And even 25 or 30 years ago, it'd be really, really slow. And if you've used ChatGPT, people have used ChatGPT in here, you have used it, it's pretty fast. And then you can write a country western song with it. There's a lot of things it can't do, but it's just, and that's because of what's happened in technology. I know that Elon Musk I heard he has a lot of weird stuff going on. He's in a cage match with Mark Zuckerberg, I heard, or something. But he has just he started an AI company, bought a bunch of GPUs, he claims, and he's building another AI company. I don't know how a guy finds the time to do all that stuff. So AI is based on neural networks, an artificial brain, if you will. So this is sort of the core of what it does. And I'm running out of time, so I'm just kind of skate through these remaining slides. A neural net is a simulation of a neuron, a collection of neurons that can be taught. And it's trained, and the neuron connections are preened, it's a modeling the human brain, in other words. And so this is a neural net. There's an input layer, hidden layers, and an output layer. And originally, it was used for image recognition and so forth, but it's found much broader applications, natural language, and so forth. It'll be interesting to see what happens when you're running a political campaign and this interjects itself into the system. I don't know what's going to happen. It could be crazy. So are they dangerous? No, they're not. Just by my former example slide, the information it gets from the web, and that's what it knows. So TPU is the tensor processing unit. I'm out of time. I got to wrap this up. I mentioned what a TPU is, and that's essentially what you buy a GPU. This is basically what you're using. So most of the work now is a specialized processor called a TPU instead of a GPU. And thank you. I'll be around for